students. Welcome to my YouTube channel. And as you know, this channel is all about physics of ICSE class 9 and 10. In my previous video, I have discussed about different characteristics of alpha, beta and gamma, harmful effects of radiation, background radiation. Today is the time to know about the nuclear reaction. So let's start our nuclear physics part 3. This topic is all about nuclear change, nuclear reaction, type of nuclear reaction. So, we'll come to nuclear reaction. Nuclear reaction is of two types. One is nuclear fusion, one is nuclear fission. In nuclear fission and nuclear fusion, one basic difference between them is in nuclear fission, one heavy nuclei break down to two fragments. Whereas in nuclear fusion case, two lighter nucleus combine to form one heavy nucleus. Means one case it is a breakdown, whereas other case it is the combination. So in this video, in detail we'll read about this nuclear reaction, types of nuclear reaction and their properties. So let's start today's video, whose topic of discussion is nuclear reaction. Here, first thing to know, what is a nuclear reaction? So, nuclear reaction means what? Nuclear reaction means the changes inside the nucleus of an atom. How it will change? When any energetic particle bombard means to strike from with a very high energy. So, when a neutron will bombard, when an alpha particle will bombard, when this energetic particle will hit to the target, then the change in the identity of atom is the nuclear reaction. In the nuclear reaction, there is change inside the nucleus of an atom. This bombarding particle must have high amount of energy because inside the nucleus, force of attraction between proton and force of attraction between the neutron is the nuclear force, and nuclear force act within a very short range. So to break that force, strong force of nuclear force or strong force of attraction, we need a very energetic particle. So the particle which will bombard has very high amount of energy. This one first time given by Rutherford by bombarding a alpha particle to nitrogen. When alpha particle hit to the nitrogen, it changes to oxygen. This is 1990. So if we'll come to the definition of this nuclear reaction, nuclear reaction means what? Nuclear reaction is that process in which two nuclei or nuclear particle collide. Means one will hit to another, and in that a new product will come. We got in the alpha particle, we got in the beta particle also. One is parent nucleus, and after emitting alpha or beta, it is coming to daughter nucleus. So changes what will occur, the parent nuclei and parent nucleus and the daughter nucleus. That is the nuclear reaction. The nuclear reaction is the process in which two nuclei or nuclear particles collide to produce different product than the initial. Initial is called parent, product is called the daughter. So in this nuclear reaction, we'll get one more thing is the mass defect. What is that mass defect? And with that Einstein equation, most popular equation given by Albert Einstein, E equal to mc square. Here we will discuss about that. What is that mass defect mean? Mass defect actually, whenever we will take a nuclear change, parent nucleus, how much the mass, and daughter nucleus mass, it will combine, it will compare. Every time we will see that reactant side and product side are not having the same mass. The mass of nucleus actually little bit less than the individual proton and neutron. So that difference of mass is called mass defect. In case of chemistry or chemical changes, it will go. In case of chemical change, mass of reactant always equal to mass of product. But in case of nuclear change, mass of reactant is not equal to mass of product. So that difference of mass is called mass defect. So that mass defect, that difference of mass, where the mass will go, that mass defect that changes in mass, that difference in mass, that amount of substance or that amount quantity of matter changes to energy. That energy which bind the proton and neutron inside nucleus with a very strong bond. That energy is called nuclear binding energy. That means mass is changing into energy. So what is the nuclear binding energy then? Nuclear binding energy is defined as energy required to hold all the proton and neutron within the nucleus. The force of attraction and nuclear force, the amount of energy because of which proton and neutron remain inside the nucleus is called nuclear binding energy. And whenever binding energy is very high, that time the nucleus is very stable. So binding energy between proton and neutron will decide when nucleus is stable or unstable. In the nuclear reaction, how much amount of energy will release, that also decided by this binding energy. At the binding energy, more stable is the nucleus. But when you will take that type of nucleus where binding energy is low, then it will come to nuclear change or nuclear reaction. In this nuclear reaction, very heavy nuclei and very light nuclei both are having the low binding energy. Means two type of change. One case, heavy nuclei breakdown. Second case, lighter nuclei combine. So first one, if we look, when a heavy nuclear will release energy when split apart, means when it will break down, that's what we can call as the fission. Whereas when two nuclei join together to release energy, that is what we can say as the fusion. So one is fission, one is fusion. Two type of nuclear reaction. So here it is the mass defect. So what is that Einstein equation about the nuclear physics? In nuclear physics, the relationship between mass and energy. If I look in Einstein equation, the mass defect, the difference of mass between the parents and daughter nuclei is different. That mass or difference in mass is changing into binding energy. It is changing into energy equal to delta mc square. Delta m change in mass, c speed of light in air or vacuum, which is 3 into 10 to the power 8 meter per second. Means here there is a relationship between mass and energy. Some amount of mass is also changing into energy because speed of light in air is very large, 3 lakh kilometer per second. For that, even a small amount of matter, a small mass also can convert into tremendous huge amount of energy. And after this, which energy will get, that energy is called nuclear energy. 1 kg of mass, if we will compare, 1 kg of mass will give how much amount of energy? Then 1 into 3 into 10 to the power 8 whole square means 1 into 9 into 10 to the power 16 joule means 9 into 10 to the power 16 joule, very huge amount of energy released from 1 kg. This equation means this nuclear energy can be used for destruction in nuclear weapon construction, but in nuclear reactor to change into electric energy. To measure this high amount of energy, we are using another unit. That unit is called MeV, mega electron volt. 1 mega electron volt is equal to 1.49 into 10 to the power minus 13 joule and 1 AMU, atomic mass unit. 1 AMU is 1 by 12 part of 1 mass of 1 carbon 12 atom. 1 AMU equal to 931 mega electron volt. So it is the relationship between mass and energy. And then our topic now is nuclear fission. What is that nuclear fission then? We got two type of reaction. One is nuclear fission, one is nuclear fusion. So first one we'll discuss now here about the nuclear fission. Nuclear fission means when a heavy nucleus, which is having number of neutron more, number of proton more, it will break down into two lighter nuclei. How it will change? Whenever a fast or slow moving neutron will hit, then it will changes to very small particles or very small atoms. Sometimes one heavy nucleus, when neutron hit to it, changes to two more atom. That two atom again unstable. It can continue again the further reaction. So that is also possible. This nuclear fission was first discovered by German chemist Otto Hahn and Fritz Strassmann, and they took uranium 92 atomic number, 235 mass number for nuclear fission, and nuclear after each nuclear fission uranium 235 give nearly 190 mega electron volt of energy. So here you can see uranium 92 235, when a slow moving neutron hit to it, then it will change to uranium 92 236, which is unstable. Uranium 235 plus 1 neutron, and it will come to uranium 92 atomic number, 236 mass number. It will change to two atom. One is barium and one is krypton. But this one given by Otto Hahn and Fritz Strassmann. But after that, they got the different other fission reaction also possible from this uranium 235. So another one, if you look here, uranium 235, when a slow moving neutron hit to it or bombard to it, we can say hit, not bombard, with a very high amount of energy when it will hit, then it will change to uranium 236, and then after further reaction, this unstable uranium 235 changed to 36 to barium 141, krypton 92, and most important one is this 3 neutron with certain amount of energy. This energy is the nuclear energy, 3 more neutron. And another one reaction, if you look here, uranium 235, one neutron hit to it, it changed to uranium 236, and uranium 236 again changed to La 148 and Br 85 with 3 neutron. Next, another example if we take, here you can see uranium 235, when a neutron hit to it or bombard to it, it changes to uranium 236, and again after the reaction we got Xe xenon 144 and Sr 90 with 3 neutron and high amount of energy released from it. And this all is the nuclear fission. Isotope of uranium means for nuclear fission, which isotope of uranium will use. What is isotope? With same atomic number, different mass number. Uranium having 3 isotopes: uranium 235, uranium 236, uranium 238. But 236 is fully unstable. 235 and 238 are, in compared to 236, it is stable. So if we take uranium 235 and 238, 235 uranium 92 atomic number, 235 mass number, mostly used for nuclear. Why? Because uranium 238 require a very high speed of neutron, which is every time not possible. So uranium 235 atom is fissionable with a very slow moving neutron also. For that reason, uranium 235 is more easily fissionable. More easily it can go for nuclear fission to give krypton and barium. Here you can see also uranium 235 now changes to uranium 236, and we got two parts, 92 and barium 142. So uranium 235 is basically used for nuclear fission reaction. So next one, here you can see chain reaction. What is the chain reaction? Means in the nuclear fission case, we got that after the nuclear reaction, 3 neutron come. That 3 neutron again hit to different uranium. Here you can see, if we look this part, here it is the first uranium 235, when a neutron bombard to it, it gives barium, krypton and 3 neutron. That 3 neutron again hit to different uranium. Again this process will continue. Same process when it will continue, then it will give very high amount of energy, and always it will go in a form of chain. Means one uranium 235, one neutron hit to it or bombard to it, it gives uranium 236, then krypton then barium and 3 neutron. That 3 neutron again hit to different uranium 235. Again this process will continue. So this continuous fission reaction till entire uranium will consumed, coming in a chain. So that chain is called is a chain reaction. This chain reaction can be controlled, can be uncontrolled. So you chain reaction having two type. One is controlled chain reaction, other is uncontrolled chain reaction. Controlled chain and uncontrolled chain reaction then. So here the types of chain reaction. First one, if we look, whenever these 3 neutron comes after uranium 235 bombarded by a neutron changes to uranium 236, uranium 236 again gives 3 neutron, that 3 neutron again hit to different uranium 235, then same process continue, and at once means a very small interval of time they will emit very high amount of energy which is very difficult to control again. So very short interval of time, strong explosion will take place, very high amount of energy will release. That all we can say the uncontrolled chain reaction, because it is very difficult, to control that much amount of energy. So that is called uncontrolled chain reaction. But if by using a cadmium rod which is used mainly to absorb the amount of energy, or it will take a moderator like hard water will take. So in that case, it will able to control how much amount. If we look the nuclear energy, when we are changing nuclear energy to electric energy, we are using different process. Cadmium rod used, it is kept inside lead box, then it is passing through hard water, heavy water we can pass, then it is going through radiators. So this all process if we are able to control the energy, it is called control chain reaction. So two type of chain reaction, one is uncontrolled chain reaction, one is controlled chain reaction, where reaction is not in our control, so it gives destruction. It is nuclear bomb, atom bomb in that category. But when you are taking controlled chain reaction, this main purpose is the constructive purpose in nuclear energy to electric energy, which is mainly used in the nuclear reactor center. So two type of chain reaction, one is uncontrolled, in a very less time, high amount of energy will come. One is control, means we are taking the energy from uranium, but the time span is very long. So here another one, if we look, is a nuclear fusion. One type of reaction, a nuclear fission, where a heavy nucleus break down to give lighter one. But nuclear fusion case will get that opposite, means in this process two light nuclei will combine to form a heavy nucleus, means small nucleus join together to form heavy. In this process also very high amount of energy release. Here also mass of reactant, mass of product not same, and that change in mass or that difference in mass, that mass defect is changing into energy, the nuclear energy. So when fusion happens, the product have larger binding energy than the reactant. Means reactant are very small nucleus and they join together to form a heavy nucleus. So heavy nucleus having larger binding energy. Heavy nucleus can give out, or during this process of fusion when small nucleus join to form a bigger one or strong one, we can say, in that case also this difference in mass is giving a huge amount of energy. Nuclear change time will get high amount of energy, tremendous amount of energy we can say, because mass is changing into energy. In that mc square E equal to mc square, where c is the speed of light, which is 3 into 10 to the power 8 meter per second in air or vacuum. And if we look the reaction here, some example, hydrogen, we know that it is having three isotopes, H11, H12, H13. Here H12 when it will react with H13 combine, we can say, here it will give He24. He is the helium plus one neutron with 17.6 mega electron volt of energy. Another one, if we look, H12 combine with H12 to give He23, which is unstable again with one neutron, and it is giving 0.5 for 2 mega electron volt, means H11, 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 4 times also they will join to form helium 2,4. Means nuclear fusion case, lighter nucleus is joining together to form a heavy one. So in nuclear fission case, we got that heavy nucleus breaking into small. Now we'll get thermonuclear reaction, means the nuclear fusion, why it is known as thermonuclear reaction. Thermo, we know, thermo means heat. So why this nuclear reaction is called heat nuclear reaction? Because in this nuclear fusion, two nucleus will combine. Nucleus again having proton. Proton force of repulsion. To break that force of repulsion, electrostatic force of repulsion, we need very high amount of temperature. It is nearly 10 to the power 7 Kelvin. Means extreme high pressure, extreme high temperature is required. In normal condition, fusion is not possible. So, for at such high temperature, both these nucleus overcome the force of repulsion, then they fused, then they combine. So that's why nuclear fusion is called thermonuclear reaction, because it is possible only in a very high temperature. Fusion of light nuclei give more energy than fission of heavy nuclei. Means fission and fusion, if we compare which is giving more amount of energy, then always fusion will give more amount of energy. Why it is giving more amount of energy? For same mass, number of light nucleus is more than the heavy nucleus. In heavy nucleus case 1, but in a fusion case, if you look, number of light nucleus is more. For that reason, for each same mass, per unit mass, fission is having less amount of energy, or energy obtained by fission is less, but fusion is more. So fission, we are using the nuclear fission reaction to get the energy for destruction or construction, or constructive purpose and destructive purpose. But there is no such reaction like nuclear fusion, of no process like nuclear fusion will give us the energy for any. The difference between nuclear fission and nuclear fusion. Here you can see it involves the breaking of heavy nucleus into lighter one. The nuclear fusion case, it involves two or more light nuclei joined together to form a heavy one. Larger number of isotopes are formed in fission, but in fusion no isotopes form. Difficult to control fusion, but fission can be controlled. Nuclear fission having a chain reaction, that may be controlled chain reaction, uncontrolled one, but nuclear fusion case no chain, such type of chain reaction. Nuclear fission does not require any temperature, it requires only one fast or slow moving neutron for the nuclear fission process. But fusion process is initiated by a very high temperature. Nuclear fission case, if you look, it can be controlled by using cadmium rod and all, but nuclear fusion very difficult to control. And many more difference between this nuclear fusion and nuclear fission. This is the two type of nuclear change. So nuclear reaction means whenever a parent's nucleus, by bombarding a neutron or by splitting or by combining two or more lighter nucleus, will get a daughter one. This is nuclear reaction. So nuclear reaction is possible inside the nucleus between proton and neutron, or neutron and nuclear force, and the energy between them is the binding energy. Here you got two type of nuclear reaction. One is nuclear fission and one is nuclear fusion. Fission case, one heavy nucleus break down into smaller one, but fusion case, smaller nucleus or lighter nucleus combine to form a strong one.